All right. Today we are doing the question copy list with random pointer. So let's just read through it. A linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list, and we have to create a deep copy of it. The deep copy should consist of brand new nodes where the value is the same as original node, and the next and random pointers are correctly set. None of the pointers should point to the original node in the list. And then we got to return the head of the copied list. And okay, so now it's just representing the input and output. The input array is given by the value, and the random index is the index ranging from 0 to n minus 1 of the random pointer. So it's kind of easier to see it from an example over here. We have a linked list 7, 13, 11, 10, 1, and next pointers are obviously sequential. So the next pointer of index 0 is set to 1, that of 2, the next pointer of 1 is set to 2, next pointer of 2 is set to 3, right? So that is just sequential. The problem is random pointers. They could go anywhere from anywhere, or in some cases the random pointers are actually null. For example, in case of 7, and we need to create a deep copy. Now, if we didn't have random pointers, then it is quite simple. We can just traverse the array. We can just traverse the linked list, and we can create new nodes and set new pointers as it is. But the problem is we can't reliably take the random pointer, right? Because no idea where it's going. It could just reference null, and then we're stuck in the null pointer error use case. So how could we do this? Well, one thing is simple. To create the new nodes, using the next pointer is the simplest thing. So that is what I'm going to do. I'm gonna use the next pointers to keep a copy of things. And I could technically use a reference between old to new nodes save reference. This would help me because I could, once new list is there, to set random pointers, traverse the array, traverse the LL linked list, and then set random pointers. So this is kind of going to be a two-step approach. First thing is create a new list and mapping between old to new. And then the second point is going to be use the mapping to set random pointers on the new linked list based on old linked list random pointers, right? So it's kind of not that difficult to do, or like it's not that difficult to think about, but let's code and see what can be done. Yeah, so let's do it. So the first thing obviously is going to be old to new mapping. It's going to be a hash map, and then I'm going to create a dummy head node, so it's easier for me to, take care of things. And I'm just going to initialize with a value of, like, I don't know, -1, because this is just a dummy. And now I'm going to traverse through the original linked list, right? So we're given the head of it, so I can set the current pointer to be the head, right? And while current pointer exists, I am going to create a new node. So new node is going to be node with the same value as current dot value, right? And I also need access to prev. So yeah, if prev exists, then prev dot, or like this is going to be new, right? Okay, so this is going to be prev. So if the previous exists, then previous dot next is going to be new node, right? And then I'm gonna set previous as new node, and then cur as cur dot next, so we don't get stuck in infinite loops. And I also need to add the maps here. So old to new map. I have well, I don't think there are any repetitions, but even in case there are, right? So we'll just check if cur in old to new, then there should not be any repetitions. Oh no, there are repetitions. But then current, okay, cur is reference to a node. It's not the real node. So there are not going to be any repetitions. The values could have repetitions, but not the actual pointer, I guess. So if cur is going to be new node, right? So once this is done, step 1 is taken care of. I have a current and head, and current as head, and I'm creating new nodes. I am updating the old to new mapping, and if there was a previously created new node, then I'm of course setting its next pointer as this particular node. And then of course I'm again updating the pointer of the new prev, and with the new node for our next loop. And then I'm updating the pointers for the current, which is coming from the old node, of course. So this is step 1, and now step 2 is going to be now we have to set the random pointers. So yeah, so kind of doing the same thing again. Now I have current as head, so while current, I should keep doing it. I don't need to create a new node. Let's see. Okay, if cur dot random exists, right? In that case, new node would be old to new mapping and cur, right? New random node is going to be old to new mappings cur dot random, because we created the mapping for all of the nodes. So that means this is guaranteed to exist as long as cur dot random exists. Now I just need to set new dot nodes random pointer as new random dot node. That is it. And if current's random pointer doesn't exist, then I don't really need to do anything, because by default the random pointer is none, right? So all I need to do is just next, so we can keep traversing. And that is it. Okay, so the new prev is going to be dummy node, so I have reference to it. And then I don't need to check this because obviously new prev always exists. And so dummy nodes next is going to be new node because that is what we started with. So to return it, I could just return the next pointer of this dummy, right? Okay, so let's get started. Let's do this. So I started with current equals head, which is 1. I created the new node with the current value. Then I set the mapping between current and the new node. And then I updated the newly previous to new node. So at this point, this is 1. And then I updated the current pointer to current.next, which is 2, right? So now here I come, it's 2, created a new value, new node of 2, old to new mapping, done, new previous, new node is now 2, and current.next is gonna be null. So my loop ends. Correct. Now, what to do next? So now I need to restart the loop for the second part, and I started with current equals head, so I'm here, and I see that 1 has a random pointer, right? So I access the new node that corresponds to 1, right? So this is now new node 1, and I also need to get access to newly created node for cur.random. So cur.random, it points to 2. So that means I have access to new 2, right? So now I just set new nodes random as newly created random node, which is just again a reference, and that is done. And that's it. And then I update it, and we'll keep doing this until we run into the null pointer, and in the end I just return dummy.head.next, and that should be it. Let's run it. Why? Oh, so new prev.next. Okay, this was my mistake, sorry. And it's done. Again, time complexity is going to be O of n, and so is space, because for space we're using a H map for all the nodes, and time complexity is O of n because we're traversing the array n times twice, right? But the constant is 2, complexity is just n. All right, that's it.